Okay, so hopefully this works. I'll just minimize that and close that. Alright, so latest game update is the game right here. Has support for controller input, so keyboard stuff like that, and it's also got a very lightweight animation system, so you can handle like animating sprites and stuff easily. So the way that works is basically you have like an asset file, which just gets loaded in when you load in the characters or whatnot, and your animations just get thrown in there, so you can have like some animation sequences. You can see I've only got like 4 demos and a walk-up animation, just because I'm too lazy to program these right now. So you can program animations like that, and they just go right under your game character, you know, and these will be compiled in. Right now, these get you generate new assets each time the game's launched, but eventually they'll just be like saved to like an intermediate file that's like already compiled. So this stuff's like kind of one hit run. Then over here in the in the game, you have game controls where you can actually bind controls and stuff. So this is where you actually like program like what controls do. So you basically just would plug in you know, demo 1. This is what it does. It just does this callback function. It just changes the current animation to demo 1. And you know, demo 2, demo 3. Oops, don't want to do that. Demo 3. So these are just kind of like, you know, it's a lot of code, but it's like copy and paste code, and it's still pretty quick because you're basically hard coding these into classes and callbacks. So I don't think you'll really lose any performance there calling them. We may be able to abstract these out into a scripted language in the future. I mean, I could, but I don't know how much it would impact performance or if it would even be worth it, because you just have to write the script anyway. But it would kind of cut down on maybe a lot of this redundancy right here. Kind of like how the game assets, right? You don't have to program each game character. You just kind of give it what it needs, and it will generate it for you. So, like for instance, these animations don't have that you can also have a direction, but they don't have a direction, so they don't use them. So you don't have to program it in. Kind of just like bare minimum stuff. So maybe we will switch to a scripted language in the future. So that's that. And then as far as key binding goes, that's the platform's job, right? So the platform is in charge of key bindings because it doesn't really know, the game doesn't really know what a keyboard is or what a mouse is. It just kind of knows what input is. So the game basically, that's the wrong one, input queue. Here we go. The game basically just goes down, and right now it's just listening for the keyboard. But I mean, in the future, we'll have like a mouse, and it just says, okay, W, do move up, right? Case 1, do D1, it's demo 1, demo 2, demo 3. So it just calls into the control layer, and that takes care of it. The nice thing about having it set up this way is it's all in one area. So like all these buttons, and eventually I do want to break this out into like a separate control file or whatnot, so like that way you can have custom key bindings and all that. You don't have to be hard coded in here. You can change you can bind move up to whatever key you want, or if you wanted, you could even do it like as a mouse thing or something like that. So really cool because you can abstract it out, and that's about it. The game just goes ahead and it goes through to animate it again. It's just running at about I think, what would that be, 4:30. It's like 30 frames a second. No, 15 frames a second. So it's running at 15 frames a second. The animation sequences are, and then they just go down here and basically just animate among the animation. Just to kind of give you an idea of what the sprite sheets look like. Here's a full the demo sprite sheet that I'm using, and the reason why these animation this animation is like got a lot of information in it is because you need to have an ID because it has to be called into. An offset is basically where it starts in this grid. It has a width, which is how wide the sequence is, and it has a height, which is how tall the sequence is. And that's about it. These things also have an X and a Y position, so that way if you stop an animation like right here, you can jump back to it and resume animation rather than having to like start over from the beginning. And even if you didn't have that feature, you'd still have to track like the Y value, because you could, or maybe the X value, you'd have to track one of them in order to recompute exactly where you even are, because it just sees this as a one-dimensional array, so it needs to have kind of like that X or Y component in order to calculate it. But anyway, so yeah, you can see like my walk-up animation, right, starts at offset, my walk-up animation starts at offset 36, which is right here, and then it just goes for a width of 3, and it has a height of 1, so it just keeps animating this line right here. Demo 1 is just this first grid right here. Demo 2 is this one down here. Demo 3 is like right here. And Demo 4 is like her doing this dance thing right here. So this sprite I just got out DeviantArt. I think it's actually for RPG Maker. So I haven't really done... I haven't made these. This is the best one I could find, and it also had quite a few examples that I could choose from, so I just thought it would be a good test. Anyway, so that's the sprite sheet. If you run the game, just go ahead like that. Right now I only have her running. She's got this white glow around her. That was just kind of by accident. Basically what it is just when I made when I converted the PNG to a bitmap, I had like this hard edge that was still on the alpha channel. So I like it because it makes it easier for me to see. It also kind of makes it stylized. It looks almost like Trove or something like that. I mean, and that's just that's not a game error. That's just I screwed up on converting the image from PNG to bitmap. But yeah, so you can see it down here. It's failing to double buffer a lot because I've got OBS running. This is going to be all switched over. Right now, this is still all software rendering, but eventually it will be over to like hardware DirectX or OpenGL. If you actually look at Task Manager, this thing is not that processor hungry at all, which is good because it's like just a lightweight game. You can probably see it. Oh, where would it be under? It's under Java, right? So yeah, you can see right down here using like 1.4%. It basically doesn't use any processing power. And this is all software rendering. When we throw this out to GPU stuff, it's basically going to be 0, right? Which is kind of nice until we start adding like the game logic and all that stuff in there. But anyway, okay, so you can see right now she's just standing here. If I hit W, she starts walking forward. I didn't bind left, right, or sideways. It's kind of interesting. So I'm holding W to make her walk forward. That's kind of, again, like a side product. That's just because I have key repeat on, so you can see it down here, like it's adding all these button inputs because key repeat, and I just have her toggle on key repeat to cycle the animations. That's normally not how you would do an animation. That's just because it was the most convenient. It was the least amount of code to get her to do this type of action. The demos are actually bound properly. So if I like hit 1, she starts doing her full walking sprite demo, and I'm not clicking 1 anymore. I already let go of it, and she's still walking. So the idea would be like W would trigger a walk forward animation, and then as soon as you let go of W, it stops the animation. But if you're holding it down, it's not firing these repeat events. It just fires the one event at front. 2 is her falling down kite animation, which is kind of cute. 3 is, I don't know, I think she's like sleeping or something. She like waves and then sleeps or something. And then 4 is just her doing some weird dance thing, which is kind of cool. And then again, like I said, W can stop the animation and all that. So kind of neat. She can't move around the screen yet. I mean, I can physically like tell the renderer like, okay, start moving her around the screen. But right now, there's no game component that's moving her around the screen. That's all going to be built into the physics engine. I kind of had an idea about how to do it. We're going to have like vectors and stuff. So like she'll have like an x and y vector, maybe a z vector if we want to introduce some sort of like jumping ability in the game. But we'll start out with just like an x and y vector, and basically when you hit W, right, it will just add on to the y vector or subtract from it if you hit S. And left and right would just change the y vector. The cool thing about that is right now we're bound to digital buttons, right? WASD. So even if you go into the game here, you can see under the game controls. Yeah, so we have this like move up function, and we have move up digital, and we're also going to have a move up analog. So the digital one basically is just when you create your object, it just basically comes right in here, and you basically choose if you have an analog player or a digital player. This gets set by the platform. So the platform's going to tell the game, okay, they're using a controller, or okay, they're using like a mouse and keyboard to control the player. And you can switch this in game too. You can just rebind it then, or you'd have to create a new object, but we could work it out so you can switch in game. But basically, when you create the player, it creates either a digital person or an analog person. So and maybe I might be able to combine these two in the end. That would be really sweet if I could. But that way we could have like a separate kind of way of handling button presses. It's like you're always going to be moving your full speed if you hit W, right? You're just going to move your full speed forward, or maybe your full walking speed. You can still have like a running speed, but like you'll still move walking speed forward if you hit W. If you're using like a joystick, we could have that speed change with the position of the joystick. So that would be like an analog input. You'd be moving faster if you had the joystick all the way down, and you'd be moving like half speed if you only had it halfway down. So that way we can have like, and those vectors will allow us to do that. We're not set to like any like. It's not digital. We're basically, the vectors allow us to have a nice clean analog movement. And the cool thing about that too is we can add to the vector, like if the physics engine says, okay, you got hit with like a boulder or something like that, we can just like say, okay, it's coming from the left, so we're gonna just add on this boulder's velocity to your velocity in the x direction, and it will push you through the physics engine. So the physics engine was really scary at first because I thought it was going to have to handle like all this complicated animation stuff that I didn't want it to handle. But I don't think it will anymore. It's just going to handle like these vectors. It's still going to have to try to like figure out, well, it's a physics engine, so it's going to have to like take in like how much time's passed during the frame and like calculate intermediate collisions. So like if you're walking, right, it can't just calculate you're in position. It will actually calculate a vector and see if two vectors collide. And if they do collide, then it would have to go in deeper and see at what points do they collide, and if they're, collide at the same time. All right. Yeah, so that was the game. I just wanted to give you a little update. It's kind of a long video, but I was kind of happy because everything worked. The parser is like updated too now, so like we can have like these arrays. So the parser can take in arrays. It can also take in like objects. So like here I'm kind of using both. I have an array of objects, right? And it can handle that. The only thing that it doesn't really do super cleanly yet is I have to clean up a lot of the code a little bit. Part of it's kind of gummy, but it doesn't handle like types too well. So like for instance, this, it knows it's a string. I mean, basically everything's a string, right? If you put a string in quotes, it just doesn't escape white spaces or stuff like that. So like down here, he was okay, but like down here, I had some that were like I don't even know, but it would like try to escape like maybe the comment or something like that. So if you put them in double quotes, you can have spaces, just won't escape them. But like everything else is just interpreted as a string, and then when it gets down farther into like how to interpret what a game character is, that goes ahead and it says, oh, okay, this number is going to be an integer, this number is going to be a float, stuff like that. I would like to have the objects it handles as objects still. So like the object is, as far as it's concerned, it's basically an object. But like the sub elements are still all strings. These are all strings. They just get kind of cast, or they get converted into whatever element they need to be later on. So I would like to have the parser to be able to just automatically kind of determine what stuff is. Like say, okay, this is a string, right? And say, okay, this is an integer. X, we would assume to be an integer, but if you added like a 0.0, would assume it to be a float. Stuff like that. That way, there would be a lot less gunk in casting when we get down the line. I know. I think it has to go with Java's being so anally type safe about everything. Like C's pretty type safe, but Java's ridiculous. I mean, basically, even if you're gonna cast something, in C, it's like you just get a pointer, you get a void pointer or something like that, and you just cast it into whatever you need it to be. You can cast it into an integer and a string, and it's fine with it. In Java, it's like you do something like that, you get an object pointer, you try casting it, and then it's like, well, here's a unchecked cast warning, and it's just a nuts. I mean, seriously, some of the stuff for the interpreter here, I'll just show you kind of an idea of like how much casting goes on here. Like look at this. So I have to declare like what type it is, and then I actually built in like a casting function and like see how convoluted this stuff gets. It's just like so gunky. Or like here, right? So you have a list element that takes in key list elements that has a string and a key list element with a string and a string, and that's equal to the head. I mean, literally, that is way too much type declaration. So I'm gonna have to figure out how to rewrite this so we don't have to do just on my side of it. When I come down here and I start programming like the interpreter and stuff, I don't have to like deal with all these type safe casts and all that stuff. And like you can see down here, right? Like we still have to cast like the values to strings. That's what I mean. I'm casting them down here, or like to floats. I'm making new floats or integers, based off of them. But it would be nice to basically have just this like automatically track stuff like that. Maybe it won't though. I don't know. Java's kind of, it likes its type safe stuff. So, all right. Or a strong cast, I think is what they call it. Or a strong type. My bad. All right. I've talked for enough. I got to get ready for school. So, bye.